Yeah. Okay, so yeah, okay, good. You made me full screen. Little setup here that lets me present and be on screen at the same time. So I'm sorry in advance. So I didn't actually have as much time to prepare as I wanted. Oh, is my video flipped? Or is that just flipped for me? I'm okay, good. That was really confusing. Yeah, so I'm gonna just go through some old content I had here. Of course, I'm joking. Sorry, I couldn't resist a little April Fool's joke there. No, the real talk is this is fine. Interesting thoughts on tech debt. So, as was mentioned, I think this is really relevant for anybody, even if you're a contractor. Most of the time, we're building things before we know what we're building. So, thank you for coming, and yeah, I hope everybody learns something. So, a little bit of introduction. I'm a full stack developer. Have been for professionally for about 15 years, still learning every day. I love playing and learning how to make VR games in Unity. I love cooking, and I love like fantasy shows. I'm really excited about Witcher Season 2, even if it's going to be a little while before it comes out. Yes, it did, Kelsey. I'm excited. So yeah, I'll jump right into it. I'm sure all of you or most of you have seen this cartoon. I don't know what it is about this cartoon. From the first moment I saw it, it felt very relatable. I guess another image that I've seen often that just always feels relatable for some reason is this one from IT Crowd. I'll just put this fire over here with the rest of the fire. Sometimes in development, it feels like we end up having to do those sorts of things. Maybe not literally, but again, it is relatable. And so why are these images so relatable? I think it's that we often have to, ignore one fire in order to deal with another one, or just like shipping sometimes takes precedent. Stakeholders often shift priorities on us, shift priorities away from dealing with bugs and the code cleanup that kind of make us feel good about ourselves. And we sometimes have to ship something we aren't 100% proud of. Deadlines are important to companies, and obviously if we want to be important to a company, we've got to make those trade-offs sometimes. So I already touched on this, but why is this important to you? Well, I think that not having a common understanding throughout the organization you're working with can lead to a lot of lack of transparency, lack of trust, which causes you to miss deadlines, create some frustration, and eventually I think it leads to a lot of feeling of burnout when you're always, putting Band-Aids on top of the Band-Aids, and we want to avoid that. So being able to communicate clearly and reason about the software flaws with your team and the stakeholders, I think it's going to create a lot more trust and just a better, healthier relationship, ultimately leading to better innovation. So tech debt, it's just a metaphor, right? It's not something that is necessarily anything magic behind it, but it helps us discuss these issues and have a better mutual understanding of the risks and priorities in a project. So I've already thrown around the term tech debt. I guess it's probably time to define it if if it's not clear enough. So tech debt is everyone else's code. It's legacy code, and it's code in a programming language that you don't like. And of course, that's, sorry, I couldn't resist. Another joke, just full of jokes. I promise this is the last one. So it is tech debt, for real this time. The term technical debt was created by Ward Cunningham to describe the engineering trade-offs that developers and stakeholders often make in order to meet expectations. It's a useful metaphor, really, is kind of one of the big pieces, but it's used to help communicate to stakeholders that, you know, the workarounds that we have to account for, those accumulated design flaws that sort of build up over time. It's analogous to paying interest on a loan. And then the new information that you acquire over the life of a project, you're constantly learning new things. You're constantly learning what the customer actually needs, what the project actually requires. And that can help you pay off those loans in the future. And it might actually offset the cost of intentionally introducing some tech debt. I know that sounds terrible that you would intentionally do that, but I think throughout the course of the presentation, you'll kind of have a better understanding of why. And again, back to the metaphors, just having a common language really helps you convey and just communicate those trade-offs with better transparency. Oh, I guess the last one is, it's a tool to negotiate a refactor for the mess you made 6 months ago. A little quote from Robert C. Martin, Uncle Bob. Unfortunately, there is another situation that is sometimes called technical debt, but that is neither reasoned nor wise, a mess. So I've had this misunderstanding before, actually. You know, you often hear other people talk about technical debt, and you sort of kind of come to the conclusion that it's everything bad in your software, and that's not necessarily true. So what Uncle Bob here is talking about is mess. And basically that's never acceptable. So he also goes on to say that a mess is not a technical debt. A mess is just a mess. So I want to kind of dive into that a little deeper. So I've kind of split this up into two categories. So bear with me here, because for me, it helped me kind of think about things in with a little more clarity around kind of the strategies you might want to apply to these different situations. And these aren't complete lists by any means, but just to give you a little bit of an idea of what I'm talking about. So slop mess would be like a misleading code comment, poorly formatted code, obscure code, missing or broken tests. I think there's a lot of other examples you could come up with. The other category I have here is cruft. So these are the things that maybe take a little more thought to deal with. So maybe you have some duplicate code, unused code paths, which could be just partially implemented features, deprecated features, things along those lines. So why do I have the distinction? I know this may be a little hard, but again, I think there's just some different ways that you can split that up into two strategies for dealing with. And the reason for that is, I think, back to the slop, I think it's just a little easier to address that sort of mess while you're making changes. I'm referencing the sorry. The rule here, always leave the code you're editing a little better than you found it. Sorry, I couldn't quite read from my screen here. It's low risk to introduce new bugs, and it really shouldn't require much planning or team discussion. So all of this really falls under the Scout rule, which again is always leave the code you're editing a little better than you found it. So the CRUF strategy, a little different. So again, that's the duplicate code, unused code that I was mentioning. So this is a little more likely to require some planning because you'll often need to do a refactor. Still pretty low risk if you've got good test coverage. You'll probably need a separate PR. And you should probably maintain a backlog of these items and pull in a percentage of each sprint or release. That's kind of how we've dealt with it. And I'll get more into that sort of backlog strategy a little later. So another quote, another Uncle Bob quote, the decision to make a mess is never rational. It's always based on laziness and unprofessionalism and has no chance of paying off in the future. A mess is always a loss. So basically, how I mentioned how there could be some small benefits to intentional tech debt. Uncle Bob here is reiterating that we never want to make mess intentionally. We never want to cut corners. So back to debt. So I'll kind of give some high interest examples, what I think are the more costly things that you definitely want to avoid. So I would kind of summarize those all under design flaws that cause any of the following. So it's preventing you from innovating, it's reducing your productivity, it's hurting customer adoption or engagement, could be a source of ongoing bugs, or maybe there's a literal ongoing financial cost associated with the tech debt. So maybe less than good examples here is just that you think you could do a better job, or a project was written in a language or framework that you don't like. You kind of want to avoid thinking about those things in terms of tech debt if they're still providing the company value. So with that said, there's a technical debt quadrant that I found from Martin Fowler. I think it really helps to still break down technical debt into some categories like I did with mess. So basically there's 4 types of tech debt. So there's the reckless side here with the deliberate and inadvertent, and then there's the prudent side, which is kind of more along the lines of what I was alluding to, where there might be some company benefit to intentional debt. So the reckless is, we don't have time for design, we're just going to move on. We definitely want to avoid that. Versus we're going to ship now and deal with the consequences, meaning fix it later. What's layering, being the inadvertent tech debt. And then back to the prudent. We've shipped something, we've learned some, maybe some new customer behavior, we've learned something about our industry that we're in, and we can do it better now. So tech debt causes, I'm sure we can all think of these, or think of a few examples of these. Maybe we had to make a plan based on incomplete information. Maybe we had to implement a feature using an unfamiliar API or framework. We had to start integrating with a third party before the partnership was understood. And I think probably the most common is just that the business needs change faster than the code can. Choosing to skip writing tests, I think could end up becoming technical debt. And I'm sure there's other examples as well. Even mess, if you ignore it for long enough, it could become debt. So I've got a bit of a strategy here that you know, both an example of what I think is an ideal and something we're working towards at Vertical City, where I work. So we maintain a backlog of tech debt items, and we allocate a percentage of time from each. Well, we're working towards allocating a percentage of time for each sprint to address that. And you have to work with your stakeholders and decision makers to try and figure out what percentage of your time is appropriate. That might depend a lot on the stage the company is at. So then prioritizing those backlog items is really important. I think it's helpful to actually figure out what the cost is. Again, if something is not ideal, but it's kind of working as intended, might not be a good fit here. You should estimate how long it will take to address that tech debt. And then try and be really objective about what the benefit is to the project or the customer. And if it's a refactor or a replacement, just thinking you can do a better job the second time might not be a good enough reason. So a prevention item is, I think, just talking about tech debt kind of in a similar way to my presentation here, just working with your team members and talking about how to avoid future tech debt and how to prioritize existing tech debt. I think, another prevention measure is going through talking about best practices. One thing our team did was actually working through Bob Martin Clean Code. We had a little book club. Doing little things like that can really improve code quality and kind of reinforce a common understanding of what the goals are for the team. So technical debt decisions are made based on real project constraints. They are risky, but they can be beneficial. Oops. So now I'm going to move on to a pretty short video. This is actually Ward Cunningham. So that's the developer that came up with the debt metaphor. I think it's a super interesting talk, and I think it really solidified in my mind what the purpose of the metaphor was, at least the original intent. Yeah, I will try and present it. Hopefully this works for everyone.
I became interested in the way metaphors influence how we think after reading George Lakoff and Mark Johnson's Metaphors We Live By. An important idea is that we reason by analogy with the metaphors that have entered our language. I coined the debt metaphor to explain the refactoring that we were doing on the YCash product. This was an early product done in Digitalk Smalltalk, and it was important to me that we accumulate the learnings we did about the application over time by modifying the program to look as if it had been, as if we had known what we were doing all along, and to look as if it had been easy to do in Smalltalk. The explanation I gave to my boss, and this was financial software, was a financial analogy I called the debt metaphor. And that said that if we failed to make our program align with what we then understood to be the proper way to think about our financial objects, then we were going to continually stumble over that disagreement, and that would slow us down, which is like paying interest on a loan. With borrowed money, you can do something sooner than you might otherwise, but then until you pay back that money, you'll be paying interest. I thought borrowing money was a good idea. I thought that rushing software out the door to get some experience with it was a good idea, but that of course you would eventually go back, and as you learn things about that software, you would repay that loan by refactoring the program to reflect your experience as you acquired it. I think that there were plenty of cases where people would rush software out the door and learn things, but never put that learning back into the program. And that by analogy was borrowing money, thinking that you never had to pay it back. Of course, if you do that, say with your credit card, eventually all your income goes to interest and your purchasing power goes to zero. By the same token, if you develop a program for a long period of time by only adding features and never reorganizing it to reflect your understanding of those features, then eventually that program simply does not contain any understanding, and all efforts to work on it take longer and longer. In other words, the interest is total. You'll make zero progress. A lot of bloggers, at least, have explained the debt metaphor and confused it, I think, with the idea that you could write code poorly with the intention of doing a good job later, and thinking that that was the primary source of debt. I'm never in favor of writing code poorly, but I am in favor of writing code to reflect your current understanding of a problem, even if that understanding is partial. If you want to be able to go into debt that way by developing software that you don't completely understand, you're wise to make that software reflect your understanding as best you can, so that when it does come time to refactor, it's clear what you were thinking when you wrote it, and making it easier to refactor it into what your current thinking is now. In other words, the whole debt metaphor, or let's say the ability to pay back debt and make the debt metaphor work for your advantage, depends upon you writing code that is clean enough to be able to refactor as you come to understand your problem. I think that's a good methodology. It's at the heart of extreme programming. The debt metaphor is an explanation, one of many explanations of why extreme programming works.
Sorry, I'm just going to adjust here, bring myself back.
Okay, good evening, everybody. Great to be here.
Sorry, autoplay. Was everybody able to see the video okay? I'll hope that was yes. Okay, so closing thoughts. Tech debt is hard to avoid, but when it's intentional and we understand the trade-offs, I think it can be beneficial to the company. But as Uncle Bob and Ward Cunningham both have kind of repeated that, if you're going to do this, make sure it's clean code, not sloppy. Mess is never okay. Prevention is easier, at least when it comes to the inadvertent or reckless causes. Educating your team and using best practices when you're writing code. Working with stakeholders and decision makers to start paying down debt before it becomes unsustainable, I think is really important. Because everybody at all levels of the company, hopefully understand that software development is not easy. As I mentioned, we're building things as we're designing them oftentimes, or we don't know what we're building, but we still have to try. I think everybody involved is going to appreciate the transparency that having that discussion creates, and ultimately, I think you'll have a much healthier relationship with leadership. Sources here, so I will share these in the chat. Yeah, that's it. Thanks for listening. Again, I hope everybody got something out of that. Yeah, thank you.
I believe we have a question. Mark in chat was curious how you were doing the floating head thing. Is that an OBS thing, or what's the deal there?
Yeah, I'm using something called I can share the link to that as well.
I think it's a classic kind of programmer talk when you do a talk on a really interesting topic and are really articulate about it. It's like, how'd you get your head to do the thing?
Yeah.
Kelsey, did you have a question?
Yeah, I do. So I was kind of thinking about this for a little while, and it kind of occurred to me that your tech debt backlog is never going to be empty. And some things will kind of float to the top as obviously the priority becomes apparent. And there are some things that you may come to realize will never get paid off. How do you address those things, and how do you think about them?
Well, I think, again, talking to decision makers and stakeholders and really having a very deep understanding of what the company's needs are, I think is really the best way to go, having that open communication. Because if there's something that maybe if it's been in the backlog for that long, I would suspect that this is sort of a black box type scenario where, as long as you don't peek inside that box, things are working. So I think, yeah, just being open about it and communicating.
I think communication is like the key there, because at some level, if tech debt, like if the problem is something that should be solved, the arguments for it should be fairly obvious. And if you can't articulate those arguments, that points to something about not understanding the case. And that way, the traditional kind of things apply. Make sure you're talking in their language. If you're talking with the business person, talk about ROI, talk about possible impacts, right? Speak a language that makes them understand what you're saying and hopefully gets your point across. Like I think Ryan said, there's always going to be that business case, right? Where it's like, yes, this software is old. It'll cost us $500,000 to develop. We don't have that kind of money. But you can be like, on the other side of things, hey, this software presents an opportunity. This might give us $500,000 every year. So if we do it now, by next year, it'll be paid off. So there's lots of different options to figure out how you can talk to someone, because fundamentally that conversation is one about understanding.
Right.
Mm-hmm.
Cool.
There's a question from...
Oh, you go ahead. You got it.
Chris C has a question. How do you decide when to refactor versus rewriting something?
So I'm going to say, again, I think it goes back to business needs. I can think of an example from some company. So we had an opportunity to refactor some of our Windows software. We decided to rewrite using something like Electron that would allow us to be on multiple platforms. So rather than dealing with the tech debt with a refactor, I think there was side benefits to the rewrite. So I think when those side benefits exist, that's probably a business decision though, more than a tech decision, or at least there's going to be some combination of tech and business. Obviously, the more that's kind of one cohesive unit, the better. But yeah, that's my advice at least.
You put it a good way, like that side channel benefit, right? Where it's like, if you can understand a problem and completely replace it, and that might be a more modern technology, or it might be new features, or it might be a new kind of result set, or like a like target, right? Like you might be able to get more platforms. Do we have any other questions in the chat before we get over to our last speaker? I do not believe so. Cool. Ryan, thank you very much for your talk. Where can people find you if they want to find more of your stuff?
Probably Dev Edmonton Slack. I'm not really on many. I'm not on much social media, but I'm definitely happy to chat if you want to reach out on Slack.
Well, thank you very much for
Awesome.
all of your hard work on the presentation. I sure learned a lot. Maybe those videos the video that you posted in the Ruby and JavaScript channels, other people might want to see that, because that was actually a really good talk.
Yeah.
Cool.
Sure thing.
All right.
All right.